You're watching NASA TV.
Good afternoon and welcome to NASA's Johnson Space Center in Houston, Texas. I'm Sandra Jones and we're here today to discuss an upcoming spacewalk series outside the International Space Station. 2 spacewalks are scheduled in the month of October on the USOS segment. The first is October 12th. The second is scheduled for October 20th. This will be the 268th and 269th spacewalk in support of International Space Station maintenance, assembly, and upgrades. Today's briefing will address the programmatic and operational significance of the spacewalk, as well as all of the detailed procedures. Our briefers today are Dana Weigel, Deputy Manager for the International Space Station Program, Elias Murmo, Spacewalk Flight Director, Farouk Sabur, U.S. Spacewalk 89 Officer, and Sandy Fletcher, U.S. Spacewalk 90 Officer. We'll first start with some brief initial remarks from our briefers before opening it up for questions. We'll be taking questions on our phone bridge as well as on social media using the hashtag AskNASA. If you're on the phone, please press *1 to submit your question. And again, if you're on social media, use the hashtag AskNASA. So we'll now begin with opening comments from Dana Weigel.
Welcome. Thank you very much for tuning in today. We're here to talk about the pair of upcoming spacewalks, the first of which, as you heard, is Thursday, October 12th. The first one will be conducted by NASA astronaut Laurel O'Hara and ESA astronaut Andy Mogensen. We've got a science objective for this EVA where we'll be looking at microorganisms that might exist on the exterior surface of the space station. Bacteria and fungi live in and around humans, and so of course we've got these microorganisms inside the space station as well. And there are some transportation mechanisms that allow for the gas that's inside ISS to move outside, primarily vents that we have for things like life support systems. So we're really curious to understand what microorganisms we might have outside and if any of those are able to survive the harsh environment out in space. The crew will take some samples in a couple different locations and then we'll bring those down to the ground to do the analysis. The crew will also install a high-definition camera which has with it an upgraded wireless access point. That's going to help improve and extend our wireless capability outside of the vehicle. Another unique aspect of the camera task is that we will do another demonstration or test along with it. We'll fly the arm from the ground with an EVA crew member on it. Of course, we have flown the arm from the ground for many years, but in this case, the novel part is having a crew member on the end of it. During the EVA, we'll also have the crew do some fit checks to help us with the future planned upgrade of the alpha magnetic spectrometer. This will be the first spacewalk for both Laurel and Andy. Laurel will be EV1, wearing the red stripes on her suit, and Andy will have the unmarked suit. Our egress is planned around 7:30 a.m. Central Time, and the EVA duration is planned for around 6 hours. The second EVA will be on Friday, October 20th. That EVA will have NASA astronauts Jasmine Mogbelli and Laurel O'Hara. On that EVA, we hope to remove and retrieve a failed communications box. That's called the RFG, or Radio Frequency Group. We'd like to bring that box home and refurbish it so we have it available as a future spare in case it's ever needed. The crew will also be replacing one of 12 trundle bearing assemblies. The trundle bearing assemblies help rotate our solar arrays. They're attached to what's called a SARJ. That's the Solar Array Alpha Rotary Joint. We've got a trundle bearing that's starting to degrade, and we need them to operate smoothly so we can easily track our solar arrays as station orbits around the Earth. That will be Jasmine's first EVA. She will be EV1, so she'll be wearing the red stripes for that EVA, and Laura will be EV2 in the unmarked suit. That EVA is planned for about 6.5 hours. You probably heard the great news that Frank Rubio returned last week aboard the Soyuz spacecraft, so he's back home on Earth after completing a record-setting mission. He spent 371 days in space, which is the longest duration mission for a single space flight. So wonderful to have him back home with us. Looking ahead a bit, we've got a Russian EVA on October 25th. That's EVA 61 for the Russians with cosmonaut Kononenko and Chub. And then right around the corner after that, in early November, we've got our SpaceX 29 Dragon cargo mission, which will bring food, supplies, and spares, and a lot of research to ISS. So as usual, it's always busy on board Space Station. We're really looking forward to these upcoming EVAs, and with that, I will hand it to Elias, the lead flight director.
Good afternoon. Again, my name is Elias Murmo, and I will be the lead flight director for the second of the two EVAs that we have talked about so far. That's the RFG-2 removal to bring it back inside for refurbishment. Rebecca Wingfield will actually be the flight director lead for the first EVA, which we call the Microorganisms EVA. Just going a little bit more into details on the two EVAs, Laurel will actually be the one doing the microorganism swabs. There'll be a caddy, we'll show that in a little bit. While Andy, again, is on the arm replacing one of our high definition cameras, as Dana mentioned. Again, what's interesting about this operation relative to replacing that camera is we will be doing it on the end of the robotic arm on Space Station, but controlling the arm from the ground. Normally when we do EVAs, any robotic operations that are happening on board are conducted by the crew on board the spacecraft. But again, over many years, we've done a lot of advancements in being able to operate the robotic arm from the ground to do things like science experiments or replacing other pieces of equipment on the outside of the space station. So this is just expanding our operational envelope of being able to, again, operate the arm with a crew member outside. Additionally, by doing this, it actually helps us develop some ops concepts that we can apply to the Gateway program as part of Artemis. Gateway will also have a robotic arm, and some of the tests of operations that we'll be doing as part of this EVA will help us inform the ops concepts for that future program. On the second EVA, the one that I am leading, the RFG-2, as we call it, this is, again, to retrieve the radio frequency group. We attempted to retrieve this earlier this year, but had issues removing it from a stanchion that's on the outside of Space Station. Unfortunately, we really need to get the RFG off of that stanchion to be able to put it back inside of the airlock, again, to bring it home and refurb it. So teams on the ground have spent many months kind of analyzing why we weren't able to remove it last time. And we have a pretty solid plan that we've practiced and developed with an additional tool that Sandy Fletcher will show us in a little bit, to be able to remove that RFG again from the stanchion and bring it inside. Overall, the plans and preparations for the two spacewalks coming up have been going on for many months. But over the past month or so, it's been going into high gear where we've got more development runs in the neutral buoyancy lab to really hone in our procedures and plans. And then the ground flight control teams have all been practicing in simulations to look at the various contingencies to be ready on those spacewalk days to support the crew. And then additionally, the crew on board, Andy, Laurel, and Jaws, who we talked to this morning, are all studying their procedures and plans and are ready to go out the door next week. So really, we're on what we call the road to EVA. It's a very busy time getting ready for the two spacewalks over the next couple of weeks. And with that, I'll hand it over to Farouk, who is the lead EVA officer for the first spacewalk.
Thank you. And so for the microorganisms EVA, really this is kind of 3 EVAs in a single EVA. So for one portion of it, Laurel is going to be doing the microorganism sampling, and she's going to be doing that at the airlock as well as on the lab. In addition to that, she's going to go out to do the DC to DC converter unit jumper task. And this is a jumper that we're going to be installing on the P4 integrated equipment assembly task out on P4 element of the truss. So with that, we're installing a jumper to allow us to share power in the case of a contingency jumper failure. And then so while she's doing that task, Andy, he is going to be primarily on the robotic arm doing the high-def camera replacement task. After they are complete with both of those tasks, they will join together for the alpha magnetic spectrometer assessment. They're going to be going out to the alpha magnetic spectrometer, and they're going to be looking at the work site for a future EVA. So involved in this, they will need to get underneath some beta cloth, and then they're going to assess a patch panel. And then with that, I have a video to show more of the details of the EVA.
U.S. Spacewalk 89 will be conducted by Laurel O'Hara as EV-1 with the red stripes and Andreas Mogensen as EV-2. EV-1 will egress the airlock and stow the microorganisms caddy on their swing arm. EV-2 will retrieve a medium-sized bag with a high-definition camera in it. After a quick buddy check, EV-2 will translate up the truss to the port side to set up for their next task. They will drop their safety tether as well at this location. Meanwhile, EV-1 will begin the microorganism sampling by first getting a control sample in free space. Then they will flip the microorganisms caddy to get to the sample side, open the thermal cover, and then take a sample of the vestibule area with the first sample from the caddy. They will then take a sample of the thermal cover itself. When complete, they will close the thermal cover and get another sample on the aft side of the airlock between two handrails. Once complete, EV-1 will translate to the aft nadir portion of the lab to get a sample of the carbon dioxide removal assembly vent. This will be the first of 3 vent sample locations on the lab. EV-1 will then translate ISS forward on the lab to the port side to get a sample from the oxygen generation assembly vent. The last vent location is on the port nadir aft section of the lab to get a sample of the vacuum exhaust system. EV-1 will remove the multi-layer insulation to get sample on this vent and then return the insulation. When complete with all of these vents, EV-1 will translate back to the airlock. Meanwhile, EV-2 will translate to the port lower outboard camera to relocate an Ethernet cable to the base of the stanchion and to pre-stage some tethers. EV-2 will then retrieve an articulating portable foot restraint to install on the robotic arm. Once installed on the robotic arm, EV-2 will ingress the foot restraint and retrieve the bag with the new camera. Then the robotic arm will fly EV-2 over to the camera location for the removal and replacement of the new high-definition camera. EV-2 will install a handling aid on the old high-definition camera, release a cable restraint, and demate 2 power cables. They will partially release the old camera using the cam lever and install a lens cover. Then fully release and temp stow the old camera on the outside of the bag. Next, EV-2 installs the new camera, removes the lens cover, and stows the old camera inside the bag to stop its thermal clock. Then they will remate the power cables into the new high-definition camera with wireless access. The rest of this task will be dedicated to properly routing 2 power cable and the wireless access port cable to allow full pan tilt capability for the camera group. This includes installing a clamp and a strap to restrain the cables. Lastly, EV-2 will maneuver to the base of the camera stanchion to mate the high-definition wireless access port cable to the Ethernet cable previously relocated. While EV-2 works on the camera replacement, EV-1 will stow the microorganisms caddy in the airlock and retrieve the DC to DC converter unit jumper cable bag and translate to the P4-P5 interface. EV1 will need to drop a green tether to reach on their safety tether. Once at the worksite, EV1 will install the jumper cable between two DC to DC converter units that will create additional fault tolerance in the event of an integrated equipment assembly DC to DC converter unit were to fail. The old cables will be stowed on a dummy panel. When complete, EV1 will check with EV2 to see if they need any help with the camera replacement, and then move back to the airlock. EV1 will swap bags to get the Alpha Magnetic Spectrometer or AMS bag, and then translate starboard to the AMS worksite. They will stow the bag on the AMS handrail and then work to relocate a cable that is in the way of the ingress location on the truss. EV2 will be flying on the robotic arm back to the egress position. They will egress and clean up the robotic arm, including stowing the portable foot restraint and translating back to the airlock after they retrieve their bag. They will stow the old high-definition camera and then translate out to the Alpha Magnetic Spectrometer worksite with EV1. Once at the worksite, EV2 will guide EV1 into the truss near the patch panel, avoiding areas that could damage the hardware. They will work together to remove beta cloth by cutting the lacing cord. EV1 will test the connector demate simulator tool on the exposed connectors to assess access. Then the two crew will carefully swap positions to allow EV2 to access with the tool at the patch panel location. Again, being careful not to touch any harmful areas. When complete, they will take closeout photos of the patch panel and re-secure the beta cloth. Then EV2 will egress the truss element, and EV1 will retrieve the crew lock bag, and both crew members will translate back to the airlock. And that will successfully conclude US Spacewalk 89.
And yes, and I actually have a few show and tell items here. Can we get the image, please? So here is a hi-fi photo of the microorganisms caddy. You can see it has sample canisters on both sides. On the two sample side, this is our control side. So one of those canisters we are never touching, never opening, and that will remain the control. There is a second sample on the two side that we will open and wave and free space as a secondary control and free space. And then once complete, our samples that we're taking on locations at the airlock and on the lab are going to be on the 6th sample side. Now I have some hi-fi hardware to show you. So the canisters look like this, and they are sealed inside so that they are safe from anything in the environment until they are opened. Here we have the handle. These are modified old shuttle tools that have been used for this purpose. So on the handle, you stick it into the caddy end effector, and then you can just press the locking lever and rotate, and then pull the sample out like this. And this will show you on the end of it, it's a standard COTS example of a swab that we will be using for each of the sample locations. And then so we have to be very careful that this swab doesn't touch any inadvertent areas because that could invalidate the science. And then once complete, you very carefully put this back in here and then rotate it to the locked position. And then to remove the handle, you slide this down to reveal 2 levers, press them, and you can pull the handle off. So the other piece of hardware that I have here is for the alpha magnetic spectrometer evaluation that we're doing. So on the future EVA, one of the assessments that the team is very interested in is they want to use some of these cable locations for various future needs. But they need to know what kind of access they have to these various cables on this particular patch panel. So they created this DMate tool that they plan to use in the future, and this is just a simulator tool. So they want to see if they can need any modifications to the tool in order to access any of the samples. So how you use the simulator tool is they're going to stick it over the cable, careful not to inadvertently demate, because we don't want to demate any of these cables on our EVA, to see if they have access. And they will do this same operation with 12 different connectors to see what their access looks like. In the future EVA, they will choose the 3 best cable locations to see how they can reintegrate signals and information. And that is all I have for the microorganisms EVA, and I will hand it over to Sandy.
Thank you, Frick. Good afternoon. So I'll talk to the radio frequency group, or RFG EVA retrieve number 2. What we're doing is really 2 EVAs. Farouk has 3 in 1. I have 2 in 1. First half of the EVA, we're going out to the port side of the International Space Station. The primary task out there is to do the remove and replace of the trundle bearing assembly. Laurel will be doing that task. Meanwhile, Jasmine will be doing a number of other tasks. One primary task is removal of an H fixture. This is an attachment to the beta gimbal assembly. We need that H fixture removed so we can install an ISS rollout solar array later in a future EVA. She's going to also do a cable adjustment so that we have free movement on one of the camera ports outboard on the station. Then once we're done with the port side task, we'll actually come close to the airlock. We'll be on an external stowage platform, and we'll be doing a second attempt at removing the RFG from its stanchion. So we've done quite a bit of work. We understand what the primary cause of the RFG not being removed. There are 5 aft wedge clamps that are holding the box onto the stanchion. And we will show you a video and describe the EVA, and then I'll come back and show you the tool that's been designed.
This is the second radio frequency group retrieval EVA. EV1 and EV2 egress the airlock and proceed to the forward face of the truss. Heading port, the crew put down safety tether green hooks and continue outboard of the solar array rotating joint. EV1 goes to the 2 alpha beta gimbal assembly and secures a crew lock bag of tools. Using the pistol grip tool, EV1 releases 4 bolts on the H fixture and then removes it. EV1 then surveys the worksite. Meanwhile, EV2 goes to the solar array rotating joint and removes a cover, exposing a trundle bearing assembly. After disconnecting an electrical cable, EV2 uses the pistol grip tool to release 3 bolts and remove the trundle bearing assembly. EV2 photographs the surface, then applies lubricant to the rotating ring using a grease gun. Back at the Beta gimbal assembly, EV1 continues a photo and video survey of the sites where an ISS rollout solar array modification kit will be installed on a future EVA. EV1 returns inboard to the camera port 8 worksite to adjust a cable interfering with movement of the camera light assembly. After lubricating the surface, EV2 installs a new trundle bearing assembly. EV2 then certifies the worksite. EV2 surveys the worksite before replacing the cover. From camera port 8, EV1 translates inboard, down a strut, and temp stows the crew lock bag on the US laboratory. EV1 goes to the airlock, retrieves a different crew lock bag, and takes it to the external stowage platform number 2. EV1 retrieves a portable foot restraint and installs it on the robotic arm. Then EV1 ingresses the foot restraint and the robotic arm flies to the radio frequency group aft position. EV2 returns along the truss back to the airlock, stowing the large bag outside the airlock, and joins EV1 on the stowage platform. The crew work together to fold back the multi-layer insulation surrounding the radio frequency group. At the aft wedge clamps, the crew remove any rubber covering the clamp nuts using needle nose pliers. Then, using a ratchet wrench and a specially designed tool, they loosen the 5 aft wedge clamps. EV1 is then flown to the forward face of the radio frequency group, releases 4 structural bolts, then removes it from the stanchion. EV1 then flies it to the airlock, where both crew secure it inside. Back at the stowage platform, EV1 egresses the arm, removes the foot restraint, and retrieves the earlier temporarily stowed tool bag. EV2 secures the covering over the stanchion. Then both crew return to the airlock and ingress.
So this is our specially designed RFG wrench. You'll see it's got a fairly large handle. This is to enable a pressurized EMU glove to go over. We've always got a tether point so we don't lose tools during an EVA. What's unique about this is that the wrench part of it is actually very thin, and that's because our access point to the bolt is not compatible with our usual EVA tools. So we'll have one crew member holding this onto the bolt head while the other crew member releases from the nut side using a standard EVA ratchet wrench or the pistol grip tool. So with that, that concludes my part of the presentation. I'll hand it back to Sandra.
Thank you, and thank you to our briefers for those initial remarks. We will now open it up for questions. As a reminder, if you're on our phone bridge, you can press *1 to submit a question. If you do find your question has already been asked and answered, you can press *2 to remove it. When you are called upon, please state your name, affiliation, and to whom you'd like your question to be directed to. And again, on social media, we will be answering your questions using the hashtag #AskNASA. Our first question comes from Rob Perlman.
Hi, thank you. I have a couple of questions regarding EVA 89. With regards to collecting the microorganism samples, do any special precautions need to be taken before the EVA to clean Laurel's suit, or does the control samples compensate for that? And with regards to Andy riding on the end of the arm being controlled from the ground, are there any additional risks involved in that? What happens in the case of a comm dropout?
So yeah, I think I could take both those. In terms of the vents and where the swab locations are for Laurel, these are all just gases inside of Space Station that are going outside, so there's really no concerns to the contamination on the suit and no real additional precautions that we have to take relative to there. We've looked at all of the possible things that are coming out of those vents, and there's no concerns for her suit. In terms of the second question, for the end of the arm operations robotically, during the entire EVA, Jasmine will actually be a standby on-board robotic operator. So that's how we're mitigating any concerns of a comm dropout during the spacewalk. And we have worked with the crew extensively to make sure that they're ready to take over, again, in case there's any unexpected issues. And we have contingency plans for that. So from a safety perspective, no concerns. We've mitigated the risks relative to comm dropouts.
Thank you, Elias. Our next question comes from Facebook. ARMDC wants to know, what is the temperature at this height during a spacewalk?
Let's see. I can take that one. The external environment around Space Station ranges from -250 Fahrenheit to +250 Fahrenheit. And of course, we get day-night cycles multiple times throughout an EVA, so pretty large swings.
Thanks, Dana. We'll take another question from the phone bridge. This one is from Mark Carreau.
Yes, thank you. This is Mark Carreau from the Houston Chronicle, and I just have two questions. The first one has to do with the robot arm ops. Are they going to be from the ground for both spacewalks or just the first one? And second, could you just generally describe what the future alpha magnetic spectrometer work that you're sort of preparing for with this with this group of spacewalks would entail?
Yep. So for your first question, we are only going to do the test objectives for the ground robotic operations on the first spacewalk. The second spacewalk, we will have Andy operating the arm from onboard the ISS, and I think Dana will take the second part of that question.
Sure. Let's see, for your second question, you're probably aware the alpha magnetic spectrometer is looking at the composition of galactic cosmic rays. The goal with the upgrade is to be able to get more data, so more data throughput and higher accuracy. And so the terms they use with the AMS is instrumentation layers, is the terminology they use. The goal is to build and install a new outer layer and upper layer, which again will give us more data throughput, and also higher accuracy. And so there's a series of EVA tasks. This early one is really going to help, as Farouk mentioned, to understand what cabling connections could be used to help connect this future upgrade. And so that's going to inform some of the design solutions in the future. And then there's a series of EVAs to actually install the tracker and to address some of the challenges that come along with heat rejection once we install that. So those are some of the future EVAs.
Thank you. We do have a couple more social media questions, but if you are a reporter on the phone bridge, please press *1 to go ahead and get that question submitted. So our next question comes from Madhausen on Facebook, who wants to know, how do we get such good quality pictures while space station is orbiting the Earth so quickly?
Do you want me to try that one?
So I think, yeah, the pictures that we're having on board the space station, really, we've got a bunch of really nice cameras, and then we've got the cupola window. So from inside of the space station, our astronauts obviously can take amazing photos of our amazing planet. And then outside, when we do spacewalks, they take cameras, similar cameras that are just wrapped in a lot of insulation and protected from the extremities that Dana had mentioned when we're outside the space station, again, to take photos while they're on those spacewalks. Additionally, we've talked about the high-definition camera that we're replacing and upgrading on the outside of space station. So we actually have a collection of high-definition cameras that are constantly streaming to the ground when when we have a signal with the space station that, again, provides just amazing views, really breathtaking views of Earth.
Thank you, Elias. Yes, those photos are gorgeous. Be sure to follow us on social media so that you can see those photos during and after the spacewalk. We do have another question on the phone from Marcia Smith.
Thanks so much. This is Marcia Smith from SpacePolicyOnline.com, and I have two questions. The first one, is this the first time you're collecting microorganisms from the outside of the space station? And if so, what is it about the space station right now, 23 years into its life, that you want to do this? And if not, what have previous studies shown? And then separately, I'm curious, Elias mentioned about how putting Andy on the end of the arm and controlling it from the ground was somehow related to gateway operations in the future. And could you just explain that again?
All right, I'll take your first question. The Russians have actually done the most work in the area with microorganisms outside space station. If memory serves, something on the order of maybe 6 or 7 different experiments. I'd have to go and check the actual number. So they have a lot of results, and they've been studying this for a while. There are a lot of publications that are already out there, and so, of course, that's piqued our interest, and we're trying to also understand, based on the extensive knowledge we have of our environment inside, we're curious what may actually move outside with us and what might survive. Part of it's just basic biological curiosity about what can survive in this anaerobic, harsh environment. But the other part of it does have applications to future exploration and just understanding what types of interactions we might have with environments or future planets, for example, and things that we could end up bringing with us.
And then for the second part of your question, how does this apply to the Gateway program? So I think everyone's familiar. We have a Gateway program currently in development. We're in requirements. We are designing this space station around the moon that'll enable us to be a staging point for our Lunar Lander and Artemis programs to go to the South Pole. That will have a robotic arm similar to what the ISS has currently. And really, this new operation of having the ground control of the arm on board the space station is just a different way to interface through software and applications that may look more similar to what Gateway is doing. So really, this is just providing another way for us to operate the arm from the ground during a spacewalk, which will help inform those requirements and ops concept development that's going on with our Gateway program.
Thank you. And we do have another social media question. Speen Reese on Facebook wants to know if astronauts are exposed to more radiation while on a spacewalk than while inside the International Space Station.
Okay, I can take that one. They are exposed to a bit more radiation when they're outside doing a spacewalk. Of course, the suit does offer some protections, but inside space station, we have a lot of dense metallic equipment, which is a great barrier to radiation. The way our modules are designed, the equipment is located on the outer portions of the modules, and that helps offer additional protections to the crew from the radiation environment.
Thank you, Dana. We do have another media question from Robert Perlman.
Again, about EVA 89. About 16 minutes after Andy and Laurel exit or begin the spacewalk, the Psyche launch is scheduled. Do you know if the space station is going to be, at this point, do you know if the space station is going to be within view of Florida and whether they might have an opportunity to see the launch while on the EVA?
Yes, I don't actually have that answer, but we can get back to you and see if the space station will be in view of Cape Canaveral during that launch. But good question.
Thanks, Robert. We'll follow up with you on that one. Good question. So that is actually all of the social media questions that we have for today, as well as all of the questions that reporters submitted online. So thank you all so much for joining us for today's briefing, and thank you to our briefers for being here as well. I do hope that you'll tune into NASA TV to watch the series of spacewalks. The first spacewalk on October 12th is scheduled to begin at 10 a.m. Eastern and last about 6 hours. NASA TV coverage will begin at 8:30 a.m. Eastern for the first spacewalk. And the second spacewalk on October 20th will begin at 7:30 a.m. Eastern and last approximately 6.5 hours. NASA TV coverage will begin at 6 a.m. Eastern for that spacewalk. So thanks again for joining us. That will wrap up today's briefing.